Okay, this is Module 6, Lesson 17, Problem Set Debrief. Now, I just wanted to show you and actually show you what I did. So what I did is I measured from point B to the line of symmetry, and I saw that it was 3 centimeters. So I moved my set square 3 centimeters from the line of symmetry. Then I came down and I said, okay, that's 3 centimeters from the line of symmetry as well. And as sturdy as I could, I pulled it over and marked that. Now, using my set square, I'm going to connect these lines, and they should be as symmetrical as I can make it. Okay, now the same thing goes for down here. What I would do is find an easy measurement. Okay, so that's 4 centimeters. So I'm going to take this, and as sturdy as I can, I'm going to move my set square and connect that line. So if it's 4, then really and truly I know it would be 8 because there would be 4 on that side. Now, here, how far is this line from this point? So it looks like, I don't know if it makes more sense to use the inch or the centimeter. So the line is about 1 2/8 down, but how far across is it? How far from the point is it? So see how I'm using my set square to figure out the distance? Okay, so it's about 3. It's about here. And it's about how far down? It was 1 2/8 down. And 3 inches in. So that's what we're trying to do. I'm using my set square to measure. So if this was 4 on this side, it's got to be 4 on this side. Then I have how far down does this point go? It might go down here. Oh my gosh, this one's going to be definitely more difficult. So, it's got to go up. So if you fold this, it's got to go upward. So if this folds up, it's got to go up in this direction. All right, so use your set square, and now that we got that straight, come back and check your work. You could let's see if that could help you. Help you get some of those dots, those points, kind of get that general area of where those should be. That might help you as well. You might use pencil. All right, so that's what you're doing here. Then for here, you're using your set square, remember, or a ruler. So you're plotting 3 non-collinear points. So first you have to let's just draw a line of symmetry. Eight centimeters long. Then 3 non-collinear points. So if you have a point here and a point here, and here's D and here's F. Remember, DF has to be that line of symmetry. Then your D, your EF, your EF has to be a line, and your DE has to be a line. So you might want to, well, you could just draw a line that's perpendicular and make sure that they're equidistant. So if this is, let's make it 2. 2 to this side, 2 to this side. And here is G. Here is E. Now if we connected and made a quadrilateral, so we can see that D, and EF, if you folded it on itself, you could fold it on itself and create a symmetrical point on the other side. So, and then when you connect all the points, you end up with a quadrilateral. Then for problem 4, it says, Stu says that the quadrilateral HIJK is symmetric about HJ because IL is equal to LK. Use your tools to determine his mistake. Well, yeah, is if this is does this measure the same amount over here? This point, L and K, they are not equidistant. You can see that how much shorter this side is than this side, right? So then you could use your protractor to measure the angles to see if they add up to 180 degrees. So even though IL is equal to LK, the adjacent means next to, angles from the line of symmetry, which is HJ, should be the same size. So angle LJK, LJK should be equal to angle LJI. LJI. This should be equal to this. And just by looking at this triangle, you can tell this is almost isosceles here. And this is an obtuse triangle. Also, angle LHK should be equal to angle LHI. So LHI and LHK. You can tell that these two triangles are not equal. And you can find that out. You can actually measure it, or you can measure out the angles to prove it. All right. That will do it for our problem set debrief. And hopefully you will successfully complete the exit ticket and homework.